Yes, so thank you very much, everyone. It's a real pleasure to be able to present to this HDF group, HDF user group, sorry. First, I would like to thank Gert for inviting me to present the work we did. I think it's a great opportunity to share with the community what we are doing actually with HDF5. So my talk today will be about an open HDF5-based format for industrial inspection data with experimental integration of the Onion VFD for file versioning. So first, a quick word about myself. I'm Baptiste Gauthier. I'm a system engineer within our R&D department at Evidence Scientific, one of our key R&D facilities based in Quebec City in Canada. So I'm actually based in Montreal, but working for this facility. I'm basically working within the ultrasonic non-destructive testing and evaluation industry since 2016. And before I had an academic background in ultrasonic imaging for NDT. So I will shortly explain what NDT mean. And a quick word also, I would like to thank some of my colleagues that were part of this project. So thank you, Martin and Simon, and also a group of students that participate in this great project. So regarding the agenda of the presentation, I will start by who we are and what we do. I think it's important to give you a bit of context of our industrial context, just to let you know where we come from. And I think we all come from different backgrounds, so it's important, I think. Then I will switch to the quick introduction about the NDE file format that we developed, that is based on HDF5. And finally, the core of this presentation, presentation of the project and the experimental implementation of file versioning that we did earlier this year. So first, who we are and what we do at Evidence Scientific. So we actually have two different divisions. The first one is Life Science Solutions. We basically develop and manufacture microscopes for the life science industry and medical industry. We were previously known under the name of Olympus for microscopes, so you may be aware of that. So that's a huge part of the company, but another huge part is also industrial solutions. That's actually the division I'm part of, where we develop and build instruments for inspection of all kind of infrastructure in the industry. So I will focus on this specific division, which I'm part of, but just to let you know what we also do. So what we do in the industrial solution division, basically we develop tools that will prevent accidents. So the sort of tools that you can see on the left pictures, those ones are what we call portable instruments. So this kind of tools use different technologies such as ultrasound, eddy current, and also visual inspections. All kind of technologies that we use to inspect infrastructures. It can be pipelines, it can be wind blade turbine, wind blades, it can be wings of a plane, etc. So inspections are usually carried out during manufacturing of a component or during maintenance periods, such as for the aerospace industry or a plane, for example, and during shutdown periods for the oil and gas industry. So what we do is we develop tools and instruments that will help scan and inspect those infrastructures to detect any flaws or defects before any damage can happen or any accident can happen. So you can see it as basically something similar to ultrasound that you know for the medical field, but applied to the industry, plus some other technologies that we also develop. So of course, we have a wide range of solutions, and again, this is not a sales pitch, just to give you more context about what we do. We have different systems. Some of them are very tailored to specific applications, such as wind power inspection systems. Some of them are more generic, such as the one you see on the top, NDT solutions, which are portable instruments that allow you to perform ultrasound on different structures. But basically, just to give you an idea of the wide range of different products that we have. So as I was mentioning, we cover different industry from automotive to power generation and oil and gas, everywhere where the inspection and control of infrastructure is key and vital for to ensure security and safety of those infrastructures, basically. So as you can guess, all those instruments produce a lot of data, and that's why we need to have a good strategy in terms of how we handle those data, how we store those data. So in this context, I will switch to the second part of this presentation, which is about the .NDE open file format that we developed. So before jumping in the details of this file format, you may notice that it's an open file format, which is not really the usual, I would say, in the industry, because we are targeting heavy industries and I mean, huge industries such as aerospace, oil and gas, etc. It's a very conservative, usually very conservative industry usually. So it takes time to adopt this kind of mindset. So we started with an observation that in our industry, so what we call NDE, for non-destructive evaluation, basically we control infrastructure without destroying them. The equivalent of Industry 4.0, you know, the next revolution in industry, is NDE 4.0 for us. And of course, as many industries, data is key and has a lot of value for us, but also for our customers. And there is basically an increased need for collaboration and transparency across the industry. And basically, NDE 4.0 is the next big leap for us. Another observation that we made is that major instrument manufacturers such as us and solution providers dominate the market with proprietary technologies, especially proprietary file formats. And smaller companies, we often see small companies with very specialized expertise in one field or one type of failure, basically. And they want to develop their own solution based on the data that they acquired, but they have to partner with major players to develop business systems. So it's kind of a barrier to develop more advanced systems and specialized applications. So there was a need basically for an open development platform that is built on more non-proprietary standards to enable better collaboration in our industry and foster basically innovation. So we came with a platform, an open platform that we call UNIS internally. And one key pillar of this platform is the .NDE open file format that we introduced in October 2022, and that is already deployed on our last instruments, and that we will deploy on all our new instruments. So basically, the strategy that we adopted is to deploy this open file format on all our new solutions, meaning all instruments, portable instruments, software, etc. So of course, it facilitates us a lot the work because we will have the same file format across all our products, which seems logical, but I can tell you that it was not the case initially. So we launched this initiative basically in 2022 and keep working on that in the future. So of course, this file format is based on HDF5. That's why I'm here today. I'm very happy to be here again. So we have what we call the kind of a hybrid approach because where we are using HDF5 plus JSON for the structure of all the metadata. So basically, we structure the file in two different sections. The first one is what we call the public section. So it's a group basically in HDF5, and the private section. So everything in the public section is open and standardized, meaning that if you add information or a data set, you have to follow basically the structure that we put in place. Every parameter that is saved in the JSON is also documented, and all the meaning of those parameters are documented. So everything is standardized in this section, and the private section is for specific information to a given instrument or a given software, but that we don't want to generalize. So that gives you a quick overview of the structure that we adopted in terms of HDF5 structure inside our file formats. So we document everything on GitHub. So our documentation for the file format is available on GitHub at ndformat.com. We also provide sample files for our customers so they can jump basically on board of this open file format journey, do some tests, develop their own applications, etc. So everything is documented here. And just to give you a quick idea of the type of data that we have, it's mostly matrices of integers or floating numbers. As I was mentioning, We are currently mostly applying this file format to ultrasonic technologies. So it's mostly signal amplitude versus time. It can range from few kilobytes to few gigabytes per inspection. So you can imagine that in an industry where you have to keep this data for all the lifetime of the asset, let's say a plane, it represents a huge amount of data. If it's for each scan, you have a couple of gigabytes, and you have to store it for 30 years. It may represent a huge amount of data. And as I was mentioning, we are also using JSON as a string data set for all the metadata. I can go back to why we decided to go with JSON a bit later, but just to give you an idea of what we do and what we are talking about. So next, regarding file versioning, I think it's the core of this presentation. So it's a very interesting topic that we explored recently at the beginning of this year. And I will first explain why it is interesting for us and in our industry. For that, I will go through the typical inspection scenario, which is divided in two main parts. So the first part is what we call the acquisition. So basically, imagine an inspector, as you can see on the left picture, doing a scan with one of our instruments. So she's holding a probe and a scanner, scanning a weld on the pipeline, just to check whether there is defects before it goes in service. So she's doing an inspection and saving all the data from the instrument directly on the instrument in what we will call the original file, which is saved directly on the instrument in an .NDE file. And then in a second time, we have what we call the analysis. So it's very common to multiple industries as well. So typically, she will go back to his facility or his hotel or her hotel room and do some analysis of the scan she just did during the day. She will open the file on an analysis software, do some modification, post-processing of the data, annotation of the data for a final report that will be sent. She will probably save a new revision of the file, or maybe overwriting the original file. There are different scenarios that we can imagine, but that just give you an idea that there is first the acquisition in the field and then the analysis later on. So what we want with file versioning is to keep the original file untouched and recoverable while saving all the modification and annotation, analysis, and post-processing that is performed later on. And it's very important for us because the original file is very important in our industry. Just a quick example, sometimes you may take a decision during acquisition. Let's say you are doing an inspection during manufacturing. You may need to take a decision during the inspection whether it's a pass or a fail for the future of your ongoing production. And you want to be able to go back to this exact moment where you take a decision with your instrument in the field later on if there is any issue in the future. So it's very important to keep this original file untouched and not modified, or being able to recover this file because we want to be able to reproduce the exact conditions where this decision was made. So what we need is basically a linear file history without branching. We want to keep it simple with the original version and all the subsequent modifications that are saved in the same file. Of course, it also presents some advantages, such as avoiding storing multiple copies of the same file and reducing the storage burden, because if you just modify a small value or small information in the file, you don't want to save again the old file. So for that, we explore the use of the Onion VFD. So I think you had a reminder about the Onion VFD by Elena earlier this morning. So the RFC was published in 2021, and actually it was introduced in HDF5 1.13.2. So it allows for creating version HDF5 files. So it's pretty much what we wanted. Version is defined by an open write close cycle. So if you open the file in just read-only mode, you won't create a new revision. If you open it in read and write mode, it will create a new revision if you use this VFD. it supports version rollback and access to previous data versions. So again, it's right on the spot for us. And all modifications to the original version are stored in a .onion file. So it's worth mentioning because multiple solutions are mentioned in the RFC, but it's actually the one that was implemented with a linear file history, as I was mentioning, which is the use case that we are targeting. So from that, we decided to test the Onion VFD. So actually, we had a great team of students working on that earlier this year, some of my colleagues as well. And we developed an experimental implementation of the Onion VFD. So they developed a very simple UI to test this functionality. So being able to explore the file on the left and being able to display some data sets, whether it's numerical data sets or whether it's text data sets. So it's the JSON I was mentioning, also some data sets, standard data sets that we have. So you can see we can edit the different data sets, save a new revision, and it's just appear as a linear history on the right. So you are able to recover the previous version without editing those previous versions. So we were actually very impressed by, I mean, in the end, it was not that complex to implement it, and it's working well. It's just a proof of concept on our end. Of course, it's something that would be integrated directly in our software, but it's just to give you an idea of what it allows practically. And it's also a great tool for us to demonstrate the capabilities of this functionality, I mean, the Onion VFD. So as I was mentioning earlier, it creates an additional file, the .onion file. So in our case, the HDF5 file has the .NDE extension. So it's adding .NDE.onion for all the modifications. In a sense, it's kind of covering what we needed because the original file remains not modified. It's the .NDE file, and all the modifications are stored in this .onion file. There is no one file per revision. All the revisions are stored in this .onion file. So it's kind of answering the needs that we had, but again, there may be some room for improvement in the future. So few things we learned over this experimental implementation. So first, the Onion VFD is still in an experimental stage, but again, very powerful at the moment. There is not a lot of documentation or example available, so it took us a bit of time to, and especially for our students, to fully understand how it works. But in the end, as you have noticed, it works well. All the modifications are not necessarily stored within a separate .onion file. So we didn't know initially whether other aspects that were mentioned in the RFC or the strategies that were mentioned in the RFC were implemented, but actually that's the only one for now. And a few things that could be improved as well. So of course, single file support, it's kind of very important for us because we do not control the transfer of data from the instrument to, let's say, a server or NAS or something like that. So imagine that an inspector is collecting some data on the instrument, transferring it to this computer, then doing some analysis, creating .onion file. He needs to transfer those two files at the same time and make sure all those files are transferred to keep the modifications he did on the original file. So it's kind of not ideal in our case to have two files. So we would greatly appreciate having just a single file. Then the size of the Onion file, we noticed that when modifying a data set and saving a new revision of this data set, the whole dataset seems to be saved in the Onion file. Maybe there are better strategies for that. Maybe we were not using exactly the best strategy, but we think that maybe it would be worth having just the difference or something that would not save the entire dataset in a new revision. Of course, the VFD is not aware of the HDF5 structure, so it may be complex to implement as well. So we are aware of that. Finally, two other points. We would greatly appreciate having an API to access the metadata related to all the revisions to kind of list all the revision more easily. And finally, and it's a message to the community to have a wider adoption and testing of this functionality, having more feedback about that and learn more about your specific needs for your industry or your application. I think it would be great from the community to hear more about that. Because I think maybe some of our needs may be covered by the existing functionalities. Maybe some of our needs may be related to your needs, so it would be great to hear from you guys as well. Something that is worth mentioning also before concluding, there is another alternative and very interesting alternative, which is called version HDF5. It's a community project based on developing Python. It's basically a version abstraction on top of H5Py. It has a different strategy in terms of storage because it's using the HDF5 structure, creating a new group, version data, where you have all the revision of the data. I won't elaborate on that, but just to let you know it exists, and please have a look on their GitHub. It's also a very interesting solution that we did not explore, but that is worth mentioning. It's a great project as well. So in conclusion, so NDE format is developed by Evident. So it's an open format for the non-destructive evaluation and testing industry, so NDE or NDT. It's built upon HDF5 and augmented with JSON metadata. NDT workflows would greatly benefit from file versioning, as I was mentioning and explaining. And we did an experimental implementation of that with NDE files using the Onion VFD. There is still room for improvement, but again, it was very conclusive for a first attempt. And we welcome more feedback from the community regarding the use of the Onion VFD and your specific needs. So thank you very much for your attention. And I will be glad to answer your question.
May I have a comment?
Yeah.
First of all, there is an API. It's on my slide. It's called H5FD CTL function that can be used to find Onion info, revision history, and to set up and update revision annotation. So it does exist already. It's not well documented.
Okay, I apologize for that.
And another comment is that when the idea was the design allows us to put all modified data in HDF5 files, so have to have one file. Unfortunately, we still have to store somewhere information about Onion VFD itself, for example, the sizes of the logical pages that we're using for modification, right? So is it acceptable that we can use user block to store this information, or we need to come with a little bit more sophisticated system? And I don't know if you know about user.
Yeah, absolutely, because we explored as well authenticity in this project, and we were using the user block. So I think using the user block would be a great solution. Yeah.
Okay, thank you. And of course, your comment about that we're storing the whole pages, so it's a lot of redundant data. Definitely, design allows us to store only modified data. It will involve a little bit more work in building index and pointing. So thank you very much for your update, for your feedback on this.
Yeah, you're welcome.
A quick question. You mentioned that this is mainly targeting your industrial measurement segment of your business. As a life science customer of yours, I'm just really interested in, have you thought of bringing this over to the life sciences as well?
Not yet, because unfortunately, because it's two different divisions, so I don't want to say that we're not sharing information. Of course, we are sharing some information between that two divisions, but first we want to push this initiative forward in the industrial division, and maybe in the future there will be initiative in the life science division as well, but not for the moment.
Yeah, thank you.
Okay, I think we need to move on. Let's thank our speaker again.
Thank you.